Good evening, ladies and gentlemen. Tonight, we dive into the weird, wonderful, and downright mind-bending world of quantum computing. Yes, quantum computing, a term that sounds like it was made up by a guy trying to impress his Tinder date. But here's the thing. It's real, it's complicated, and it might just change the world in ways we can't even imagine. So, what the hell is quantum computing? Imagine your regular, everyday computer is a bicycle. It's reliable, it gets you from point A to point B, and sometimes it even has a little bell. Quantum computing, on the other hand, is like a teleporting unicorn. It's mythical, it's confusing, and scientists are still trying to figure out how to saddle it properly. Let's start with the basics. Traditional computers use bits, the smallest unit of data, which can be either a 0 or a 1. It's like binary code's version of, "Are you or have you ever been a member of the Communist Party?" Simple, straightforward, slightly paranoid. Quantum computers, however, use qubits. And qubits can be 0, 1, or both at the same time, thanks to a little thing called superposition. Yes, quantum computers are essentially the indecisive toddlers of the tech world. They don't want to choose between the blue sippy cup and the red sippy cup. They want both, simultaneously. And unlike toddlers, they can actually pull it off. Superposition is just the beginning. Quantum computing also relies on entanglement, which is like the creepy twin telepathy of the quantum world. When qubits become entangled, the state of one qubit is directly related to the state of another, no matter how far apart they are. It's like if you and your best friend could finish each other's sentences, even if one of you was in New York and the other was in Timbuktu. Albert Einstein called this spooky action at a distance, which is the most scientific way to say, "This is freaking me out." Now you might be wondering, why should I care about this techno-wizardry? Well, quantum computing has the potential to revolutionize fields like cryptography, medicine, and materials science. It could crack complex problems in seconds that would take traditional computers millennia. Imagine being able to simulate every possible outcome of a new drug treatment in minutes, or optimize supply chains with an efficiency that makes Amazon look like it's run by a bunch of toddlers with abacuses. But, and this is a big but, there's a catch. Quantum computers are notoriously finicky. They need extremely low temperatures to function, and even the slightest disturbance can cause them to lose their delicate quantum state, a problem known as decoherence. So, we're essentially building these machines in environments colder than Antarctica and expecting them to perform delicate calculations while avoiding a catastrophic meltdown. It's like trying to bake a souffle during an earthquake. So, where are we now? Major tech companies like Google, IBM, and Microsoft are in a heated race to achieve quantum supremacy, the point at which a quantum computer can solve a problem that no classical computer can. Google claimed to have reached this milestone in 2019, but it's a bit like claiming to have found Bigfoot. Scientifically intriguing, but the jury is still out. Quantum computing is like Schrödinger's cat, simultaneously promising and perplexing. It exists in a state of both potential and uncertainty, and we're still not sure if it will revolutionize our world or just become another overly hyped technology. But here's the thing. Whether quantum computing turns out to be the next internet or the next Betamax, it represents humanity's insatiable desire to push boundaries and explore the unknown. And that, if nothing else, is worth celebrating. So next time someone brings up quantum computing at a party, don't roll your eyes and walk away. Instead, give them a nod of respect and say, "Ah yes, the teleporting unicorn of technology." Because in a world that often feels stuck in binary thinking, the promise of quantum computing reminds us that sometimes both can be better than either or. That's our show for tonight. Thanks for joining us in this quantum journey. And remember, in the world of quantum computing, the only certainty is uncertainty. Good night.